In this video, let us solve some problems in probability. Before solving any problem in probability, it is necessary to remember some points. These are the points to remember. Probability of an impossible event is 0. Probability of a sure event is 1. Phi intersection A is phi. Null set intersection A is again the null set. Phi union any event A is A. S intersection A is A. S union A is S. A bar intersection A. The complement of A intersection A is phi. A bar union A is S. And this is the addition theorem, the statement which is true when A and B are not disjoint. But when A and B are mutually exclusive, that is disjoint, probability of A equal to is just probability of A plus probability of B. Fine. Then when A and B are independent, probability of A intersection B is probability of A into probability of B. This is when A and B are independent. When A and B are disjoint, probability of A intersection B becomes 0. That is when A and B are mutually exclusive. You don't have any chance that A and B occur together. Okay? And probability of A bar is 1 minus probability of A. Probability of A given B is probability of A intersection B divided by probability of B. This is conditional probability. Probability of A bar intersection B is probability of B minus probability of A intersection B. See, when A and B are not disjoint, this is A intersection B and this is A intersection B bar, and this area is called A bar intersection B. So probability of A bar intersection B is probability of B minus probability of A intersection B. Okay, and probability of A intersection B bar is probability of A minus probability of A intersection B, right? And then probability of A union B can also be written as probability of A plus B. And if you are asked to find probability of A minus B, it means that you should find probability of A intersection B complement. And you know the De Morgan's law, A union B the whole bar is A complement intersection B complement, and A intersection B the whole complement is A complement union B complement. And when you are asked to find probability of AB, it means that you should find probability of A intersection B. Okay, and probability of A intersection B bar intersection C plus probability of A intersection B intersection C will be simply equal to probability of A intersection C, right? Let me put it the other way. Probability of A intersection B bar plus probability of A intersection B is simply probability of A, because B bar union B becomes the sure event whose probability is 1. Okay, fine. So these are the points to remember. Let us try to solve some problems. See, the first question is, the probability of n independent events are P1, P2, etc. Pn. Find an expression for the probability that at least one of the events will occur. So probability that at least one event will occur is 1 minus probability that none of the events occur. Right? Whenever it is asked in terms of at least one, it is an intelligent way to go like this. None will occur. It means that the first event will not occur, second event will not occur, first event does not occur, and second event does not occur, etc., and nth event does not occur. Okay, this is equal to 1 minus, the events are independent, so you can multiply the individual probabilities. Probability that the event occurs is P1, so that does not occurs is 1 minus P1. Second event does not occur is 1 minus P2, 1 minus Pn. So the answer is the second option. Okay, let's go to the next question. For any three events A, B, C, what is probability of A plus B given C? See, probability of A plus B given C is nothing but probability of A union B given C. You should try to give the answer directly, but since you are in the practice stage, I am trying to derive everything. Probability of A union B intersection C divided by probability of C is the answer for this conditional probability. So probability of A intersection C union B intersection C divided by probability of C. So that is equal to probability of A intersection C plus probability of B intersection C minus probability of A intersection B intersection C divided by probability of C. So probability of A intersection C divided by probability of C plus probability of B intersection C divided by probability of C minus probability of A intersection B intersection C divided by probability of C. What is this actually? Probability of A given C, and this is probability of B given C, and this is probability of A intersection B given C. So the answer is the second option. Okay, A intersection B is nothing but AB, right? Fine. So the answer is the second option. Now let us come to the next question. What is probability of A intersection B bar given C plus probability of A intersection B given C? If you remember the points to remember which I gave, you can even directly give the answer. Probability of A intersection B bar given C plus probability of A intersection B given C. The answer will be B bar B. When you take B bar and B outside, you are going to have yes, and ultimately you are going to get probability of A given C. If you are not getting this idea, let us solve probability of A intersection B bar intersection C divided by probability of C plus probability of A intersection B intersection C divided by probability of C. Take probability of C as the LCM. So you have this even I have given it in the points to remember. Probability of A intersection B bar intersection C plus probability of A intersection B intersection C is probability of A intersection C divided by probability of C, which is probability of A given C. Okay, so the answer is the option 2. Let's go to the next question. If A1 is the subset of A2, then probability of A1 given B will be less than or equal to probability of A2 given B. The second option is the answer. Let us go to the next question. For any two events A and B, probability of A intersection B union B intersection A bar. Again the question is direct, right? We have it in the points to remember. Probability of A intersection B union A bar intersection B. The answer will be, if you want me to give the explanation, you can write it like this, right? Intersection B can be taken out as the common term. At sight, you should be able to give all these answers. Probability of S intersection B is probability of B. Okay, you can even directly give the answer as probability of B. So the answer is option 1. Okay, fine. Let us go to the next question. If probability of A is L, probability of B is M, probability of A intersection B is N, find probability of A bar union B bar. I am going to use De Morgan's law. Probability of A bar union B bar can be written as probability of A intersection B the whole bar, which can be written as 1 minus probability of A intersection B. What is probability of A intersection B? N. So the answer is option 3. Okay. Let's come to the next question. If probability of A is L, probability of B is M, probability of A intersection B is N, what is probability of A bar intersection B? I have given it in the points to remember. The one event which has no bar will come first. Probability of B minus probability of A intersection B is the formula. Probability of B is M, probability of A intersection B is N. So the answer is option 2. Okay. Let us come to the next question. I have given probability of A, B and probability of A intersection B. I want probability of A bar union B. Listen carefully, it is not intersection. Right? For intersection you have a formula. For union, what should we do? You write probability of A bar plus probability of B minus probability of A bar intersection B. Probability of A bar is 1 minus P of A, because you should bring everything in terms of the terms which are given. Okay, so 1 minus P of A plus P of B minus, what is this? Probability of B minus probability of A intersection B. So you have 1 minus P of A plus P of B minus P of B minus into minus plus probability of A intersection B. Right? These two terms get cancelled. 1 minus, what is P of A? L plus probability of A intersection B is N. So the answer is option 1. 1 minus L plus N. Answer is option 1. Okay. Let us go to the next question. Again I have given P of A, P of B and P of A intersection B, and I want the answer for probability of A intersection B the whole bar, for which I use De Morgan's law. I can write it as A bar or else I can simply write it as 1 minus probability of A intersection B. I need not even use De Morgan's law. Probability of A intersection B is N. So 1 minus N, the answer is the option 2. Okay. Let us go to the next question. Again I have changed the notations here. Probability of A is P1, probability of B is P2 and this is P3. If I ask probability of A plus B, it means that I am asking you to find probability of A union B, which is probability of A plus probability of B minus probability of A intersection B. Okay. So P1 plus P2 minus P3 is the answer. So the answer is option 1. Okay. So let us continue the rest of the problems in the next video. Thank you.